So now we will discuss some important arithmetic functions related that are available in MATLAB that is very much useful for your computation. Okay, first I will discuss about finding out the number of elements in an array. Okay, suppose A is an array. A I am representing it as 4, 3, 2, 1. Okay, now I'm closing the bracket. Okay, so A is an array which has how many elements? The number of elements is 4. So if you type length, length, length of A, you will get the answer as 4. Okay, so length of array, length, in order to find out the length of an array, you can use the keyword length. Okay, now another built-in function is minimum value. To find out the minimum value of an array, you can use min of A. So if you type the array value, minimum value is 1. Minimum value of this array 4, 3, 2, 1 is, the answer is 1. So you can get the answer min. Just to type the function min. Okay, min of A. Just like that, you can type max of n. Okay, so max of n will be giving you the maximum value. Sorry, not n. Max of A will be giving you the maximum value as 4. Okay, so length minimum, length minimum and maximum, that is very, very much useful in our computations. Okay, so please understand this. Next, in order to type a command, you can just type percentage. Okay, so this the defining array R. If you want to type a line, if you want to comment a particular line, you can just type percentage, and after that you can just go for the comment. Okay, so you are familiarized with the commenting portion of C programming. Similar to that, you can just use a percentage symbol, and the rest of the things will be appearing in the green color. The green color indicates that it is a comment. Okay, that is for a commenting purpose. Commenting. Okay, if you want to comment a group of lines, okay, suppose if you want to comment a group of lines, just right click that. Okay, just select these portions and right click that. There is an option called comment. Okay, so just press comment, so that all those things will be commented, all those lines will be commented, and you can see that in green color. Okay, so that is the comment concept. So next, we will be familiarized with another important thing, that is vectorized computing. Okay. Okay, we will be familiarized with vectorized computing. So we are already familiarized with the loops, especially for loop and while loop, isn't it? What is the purpose of loop? The loop by means of loop we can iterate things, isn't it? So here also this is one example of simply a loop implementation. Okay, finding out the volume. Finding, suppose if we want to find out the volume of some 1,000 cylinders. Okay, what you should do? You need to put it inside a loop, isn't it? The first thing will come to mind, that is I need to implement a loop because I need to find out the volume of 1,000 cylinders. Okay, so what is the volume of cylinder? Pi r square h. So pi into r into r square is r into r into h. Pi into radius square into height. So pi r square h will be the volume. How can you implement that inside a loop? First of all, you need to define r and h. That means radius and height. So radius is, here it is 1 colon 4. Just for the sake of for convenience, I am only taking 4 cylinders. Okay, for convenience I am only taking 4 cylinders. So for r equal to 1 colon 4, and for h is equal to 1 colon 4. Okay, that means 1 colon 4, what is the meaning? 1, 2, 3 and 4. H is equal to 1, 2, 3 and 4. So first we defined radius, second we defined height of the cylinder. Now if we want to find out the volume of these 4 cylinders, now what we need to do? For I equal to 1 to 4, volume of I is equal to pi into r of I into r of I into h of I. So first I will be, the value will be taken as 1. Here, here you just remember that I or the indexing cannot be 0. Okay, indexing 0 is not permitted in MATLAB. Only you can start the MATLAB array indexing from 1 onwards. That already I have told you. Okay, indexing always starts from 1 in the case of an array or in the case of a matrix also. So I varies from 1 to 4, not from 0 to 4. Okay, 1 to 4, and r of 1. What is r of 1? R of 1 means The first element of radius. What is the first element of radius? R is 1. Then R of 1 into R of 1 into H of 1. What is the first element of H of 1? H of 1 means the first element of the array H. That is also 1. So it multiplies and it is returning the result into volume array, volume of I. So this is the implementation of just a loop. For I varies from 1 to 4. Volume of first cylinder, then volume of second cylinder, volume of third cylinder, and volume of fourth cylinder. So volume becomes an array, okay, from by means of this volumes of 4 cylinders. Okay, so display volume. Then at the end of the for loop, you can display the volume as disp volume. Okay, this is simple for loop implementation. Okay, but always think that these loops are always slower compared to vectorized computing. So we need to go for, there is a need for vectorized computing. So in most of the fast scientific applications, we prefer vectorized computing. Okay, so if we can implement this vectorized computing concept, we can do that. Okay, so not in every scenario we can use this vectorized computing. So we know we don't prefer loops much, and even if there is not any other situation, if there is no any other situation, then we can go for loops. Otherwise we don't prefer loops. Why? Because loops are always slower. Okay, so we go for, just I'm going to replace this particular code. I'm going to replace this particular code. I'm not putting any loops. Okay, in a second example, I'm just replacing, just to define my R and H. Okay, radius and height. And what about the rest? Volume is equal to pi into R square into H. How can I modify this particular code? Just R and H, as I've already defined, just defining my R and H, radius and height. Then volume, it automatically becomes an array because it is taking array elements R and H. So it automatically picks up the array elements because we are defining R and H like this. Okay, so automatically picking up R and H elements, and the volume itself will be an array. Okay, so please understand this. The volume itself will be an array because it is automatically picking the radius values and H array values. Okay, both are arrays. H is an array, R is an array. So the result will be the final result will be stored into an array also. Okay, so volume itself will be an array. So the disk volume. Next, you are displaying the volume. Here I am not using any loops, not any for loop, not any while loop. So the idea is clear. This is called vectorized computing, which is much faster, and the code is looking like a compact code, isn't it? The code itself becomes more compact compared to the loops. Okay, if you are going for many loops, nested loops, we can go simply by this by means of vectorized computing, because code becomes more faster compared to going for loops. So I prefer, please go for vectorized computing wherever it is possible. Okay, next I will tell you another example. This is just suppose the voltage across a capacitor, okay, is equal to 10 into 1 minus e raised to minus 0.2t. How can you define exp? E raised to means we can define e raised to e to the power as exp. Okay, exp of minus 0.2 times t. Suppose 10 into 1 minus e raised to minus 0.2 t. That is the voltage across a capacitor. How can you implement that? This t is the variable here. Okay, so just t equal to 0 to 50. I am defining my t as 0 to 50. What is the meaning of 0 to 50? 0 is the initial value, 5 is the increment, and 50 is the final value. That is the meaning of t. I'm defining t as an array. So 1 minus e raised to minus 0.2 times t. Okay, so and plot of this v becomes an array. Here the v becomes an array, same as the size of t also. Here v becomes an array. So you can just plot t comma v. Okay, plot of t comma v. What is t has the same size as that of t. Whatever be the size of t, v also has got the same size. Why? Because t itself is an array. And here I am computing 10 into 1 minus e raised to minus 0.2 times t. It becomes an array. So I need not use any for loops here. Okay, no need to go for loops or while loop. You can just compute as vectorized computing. Okay, just then after the plot, you can label the x-axis and label the y-axis. I hope this is clear. Okay, next we will go for one important concept, that is, yes, computing the dot product and cross product of two vectors. Suppose I have got two vectors A and B. Okay, what do you mean by vector? Vector has got both magnitude and direction. You already know that vector, the difference between a scalar and a vector quantity. Okay, vector quantity means it has got both magnitude and direction. Okay, here A is equal to 156 and B equal to 238. What is the meaning of that? A is equal to 156. That is the first vector. Okay, first vector means I am just defining my I coefficient, j coefficient and k coefficient. Okay, what is my I coefficient? 1. What is my j coefficient? 5. And what is my k coefficient? 6. So what is the meaning of that? 1 into I, 1I plus 5j plus 6k. What is the meaning of B vector? I am defining my B vector as an array. Okay, so 2I plus 3j plus 8k, just defining my a and b coefficients of the vector. Okay, whatever coefficients I have for I, j and k, you can xi plus yj plus zk. So what are x, z, y and z? They are called the coefficients, isn't it? So a is a vector, it has got the coefficient 1, 5, 6. What is the meaning that 1 into I plus 5j plus 6k? B vector I can represent 2I plus 3j plus 8k. So both are vectors. Okay, let us assume that both are vectors. A and B are vectors. How can I find A dot B? What is the dot product? A dot B. So just you can type dot of A comma B. This A and B are two vectors. So dot of A comma B will give you a scalar quantity, that is D. As you know, the dot product always will yield you a scalar quantity, isn't it? So dot of A comma B gives the dot product of the two vectors and it will yield a scalar quantity D. Okay, cross product, CROSS, cross product of A comma B, A cross B, that will be a vector quantity. Okay, because it has got both I component, J component and K component, isn't it? So cross product of A comma B will give you C. What is C? C is the cross product of A comma B. So this is how you can find the dot product and cross product. Okay, let me run this code. So when you run this code, you can get the answer as, first it will define, first it will display D. That is the dot product is 65. That is a scalar quantity. And the cross product is 22, 4 and minus 7. Hope you have already studied dot product and cross product in your last semester mathematics. Okay, so what is the meaning of cross product 22, 4 minus 7? What is the meaning? 22i plus 4j plus minus 7k. That is the meaning. 22i plus 4j minus 7k. Okay, that is, we are displaying only the coefficients. D is equal to 65. That is the dot product, which is a scalar quantity. I hope dot product and cross product is clear to you. Okay, now we will discuss about complex numbers in detail. Okay, so suppose you have a complex number. So I've already told you how to create a complex number. How to create a complex number using complex, the built-in function called complex. You can create a 5 plus 3j, 3 plus 2k or 3 plus j. Like that you can create a complex number, isn't it? Now just I am representing, let me take a question. Okay, this is a question. Z is a complex number. Z is equal to 3 plus j4 into 5 plus j2 and into 2 angle 60 degree divided by 3 plus j6 into 1 plus j2. What is the meaning of that? This Z is a complex number. So this is in complex representation or complex form representation. And here you can see 3 plus j4, that is a rectangular form. Here 5 plus j2, again a rectangular form. But 2 angle 60 degree, that is in polar form. Okay, complex number representation are of two types. One is rectangular format and the other one is polar form. Okay, rectangle 3 plus j4 is a rectangular form. 5 plus j2 is also in rectangular form. But this one, 2 angle 60 degree, that is in polar form. What is this 2 means? 2 angle 60 degree. 2 means that is the magnitude and 60 is the angle. Okay, once again I tell you, 2 is the magnitude of the complex number and 60 is the angle of the complex number. Last class we have seen what is the magnitude and what is an angle. Okay, so 3 plus j4, what is the real part? 3 is the real part, 4 is the imaginary part. Here 2 angle 60 degree, 2 is the magnitude of the complex number and 60 degree is the angle of the complex number. So let me simplify this expression and express the said quantity or said variable in both rectangular form and polar form. How can you represent a vector in a not a vector, it's a complex number in a polar form? Just you type the magnitude and you type the degree, angle. Okay, just magnitude and angle, that will give you what? Polar form. Just you need to represent in a polar form, you just need to represent the magnitude as well as the angle part. That is in polar form. In rectangular form, you need to have the real part and you need to have the imaginary part. So just let us simplify this expression. Okay. So here just I am taking Z1 is equal to 3 plus 4 into j. I am typing Z1 is equal to 3 plus 4 into j because it is the first vector 3 plus j4. So that is the first complex number. Okay, that is the first complex number 3 plus 4j. Z2 5 plus 2j. Okay, that is the second one 5 plus j2. Okay, next what is the third one? Z1 I represented Z1, I represented Z2. Then what is Z3? Z3 is in complex form, not a complex polar form. Okay, it is in polar form. So what is the angle? 60 is the angle and which is in degree. 60 is the angle which is in degree, and we need to convert this 60 degree into radians. Okay, how can you convert degree into radians? Just you multiply by pi by 180. Okay, if you want to convert radians into degrees, you multiply by 180 by pi. If you want to convert degree into radians, you multiply by pi by 180. So once again I repeat, if you want to convert degree into radians, you just multiply by pi by 180. Otherwise, if you want to convert radians into degrees, you multiply by 180 by pi. Okay, so theta, how can you get theta is 60 degree. Okay, I am just representing it by theta variable. Okay, theta is 60 degree. How can I convert it into radians? Into pi by 180. So this theta will become what? Radians. The angle in radians. Now you can represent this in complex exponential form. What is in exponential form? How can you represent a complex number? Okay, magnitude times exponential or e raised to j theta, where theta is the angle in radians. Okay, so magnitude times e raised to j theta, that is the representation of a complex number in exponential form. This is in exponential form. So you need to write exp or e raised to exp of j into theta, where theta is in radians. Okay, and what is this 2? 2 is the magnitude. So just need to multiply 2 into exp of 2 is the magnitude. Here you can see, here 2 is the magnitude and 60 is the angle. So 2 is the magnitude. And now you create 2 into exp of j into theta. So that how you got Z3. Z3 next complex number. Now what is Z4? Z4 is 3 plus 6j. Now Z4 is 3 plus 6j. 3 plus 6j. Now what is Z5? 1 plus j2. Okay. So Z5 is 1 plus 2j. Okay. So all the complex numbers, you got the already complex numbers. Now you just display a message like said in rectangular form is. You just display a message said in rectangular form is. Then how can you find out the rectangular form? Just you multiply Z1 into Z2 into Z3. As you can see in this, Z1 into Z2 into Z3 whole divided by Z4 into Z5. Okay. So Z1 into Z2 into Z3 whole divided by Z4 into Z5 will give you the rectangular form. Okay, will give you the rectangular form. Okay, now you find out the magnitude of this final result. This is the final result, Z rect. Okay, just I am defining it, this is just a variable. Okay, Z rect. And how can you find out the final absolute value or final magnitude of the complex? The resultant complex number is Z rect. How can you find out the magnitude of the resultant complex number? You just find out ABS. ABS will give you absolute value or the magnitude of the resultant complex number. Okay, so you just find out the magnitude Z mag, it's a magnitude. And how can you find the angle? Angle of Z rect. That is that will give you the angle of the angle of the resultant complex number. Okay, so you just find out the angle of the so please be aware that angle will give you in radians, so you need to convert it into degree into 180 by pi, just you converting this angle in degrees. Okay, so just angle will give you in radians, that if you need to convert, you just need to convert it into multiplying by the factor 180 by pi, that will fetch you the angle. Okay, next, how can you display in polar form? So display, just I am displaying a message, this complex number said in polar form. I am just displaying a message. How can you display a complex number in polar form? Just you need to have the magnitude and phase, or magnitude and angle. Okay, so just type in an array, you just type magnitude and angle. This magnitude and angle you already found out using the last two statements. So set mag and set angle in an array. So if it is an array, you just need to put the square bracket. So just display the magnitude part and the angle part of the resultant complex number. So this is the overall idea of a complex number. Okay, just I am going to run this. So when I run this, you got in rectangular form as well as in polar form. So said in rectangular form is, what is in rectangular form? 3.5546 plus 0.50. This is in rectangular form. This is the real part and this is the imaginary part. And how can you represent in polar form? This is in polar form. Set polar is equal to 3.5. This is the magnitude part and this is the angle part. See, this angle we have converted in degrees, into degrees. So this is 8 degrees. Okay, 3.59 is the magnitude part and this 8 is degrees. Okay, I hope these examples are clear to you. Okay, so we will wind up this experiment 2. This is the end of experiment 2. So please do the lab portions. Okay, thank you.